Hello everyone, welcome back to the channel Kanu sir, and I'm your teacher Paul Kanu, and I'm back again with the same topic of HCF and LCM, and here I'm going to solve the smallest, easiest questions related to HCF LCM from algebra topic. And without wasting the time, let's start the question here. So the first question is here, like first expression, that is 3x plus 9, and here you have to factorize this term, and in a factorization the first rule of factorization is to take common. So if you find common between these two parts, then you can take the common out, that is 3 and 9. It is obviously the 3 is common from 3 and 9, that is x, plus 3 times 3 will get 9. So and hence the first expression is solved. We got the answer in a product form, in a factor form. And next is the second expression, that is 5x plus 15. So here in this example I am trying to explain you the first and the main rule of a factorization, that is to take the common digits, common numbers if it is possible. So 5 and 15 are the same multiples of 5. It means 5 can be taken common out of 5 and 15. We'll get x left here from 5x, and we'll get 3 left from 15, and hence the product form or the factors of 5x plus 15 will get 5 and x plus 3. Now we are going to find the HCF. So the HCF will be the common factor in both the expressions, that is x plus 3 is common in first expression and second expression, that is x plus 3. But when we find the LCM, we'll have to follow the same process. First we have to write the HCF, which is common in all, and the remaining numbers which are not common in either of the two expressions, that is 3 is not common but we have to copy, 5 is not common but still we have to copy, and finally the answer becomes 15x plus 3. And one more thing I want to explain you that in the previous video while I was explaining about the understanding related HCF and LCM, I have told you in a HCF it is a number that can divide the quotients, and LCM is a number that can be divided by the quotients. So HCF is a factor which can easily divide both the given quotients. Like you can take 3x plus 3 divided by the HCF, that is x plus 3, and hence the factor is divided, answer is 3. Or if you divide 5x plus 3 divided by the HCF x plus 3, then the answer is 5. But LCM, now LCM is a factor that can be divided by the quotient. So that is the question is 3x plus 9, and you can say 3 times x plus 3. So here we have put HCF in a denominator, but here LCM will be in a numerator and quotient expressions will be in a denominator, and here you can find divided, and the answer is 5. And we will take the second expression, that is 15x plus 3 divided by the second expression. So even the LCM can be divided by the second expression also, that is 5 times 3, and answer. So this proves that LCM is a factor which can be divided by the given expressions, and HCF is a factor which will be able to divide the both given expressions. Now let us go to the second question. And yes, I want to explain about this. These are the one of the most important formulas for grade 10 students and 9 students whenever they are finding HCF and LCM related the algebraic expressions. So you must keep in your mind about these formulas. They will be needed while solving the algebraic expressions to find HCF and LCM. Now let us take number 2. In the number 2, the first expression is x cube minus x y square, and the second expression is x minus y. Very simple. We'll just take first expression, that is equals to x cube minus xy square, and I have explained in the first example also the main idea of factorization or the first step of factorization will be taking common. You can see x is seen in both the terms in the expression, so you can take x common out, then out of 3x you have taken out 1, then 2x are still remaining there, minus 1, there was only 1x, so it is out, and just y square is left. Now we got the expression that is x square minus y square. It is similar to the formula a square minus b square. So you can apply this formula here now. As I have said you before, we have to use this formula time and again in the given questions. Now the solution of x square minus y square will be x plus y, x minus y. So these are the two factors of the expression x square minus y square. Simply let us go for second expression, and actually the question contains square here. So if we write x minus y whole square, you don't have to use this formula a minus b whole square, because we break them in a non-square form, but we have to separate them in a product form. So let us not use this formula, we have to break in a product form first, that is x minus y and x minus y, and hence the second expression is also solved. We have to try our best to find the expressions in the product form. Therefore HCF, then why we have written these all formulas if we are not utilizing them here? It is to be used to get back to the product form, not to break the product form into the expression, symbol expression form. So we have to find out the product form of the formulas here. Now in HCF, let us see what is common here. X minus y, x minus y. Even this is also common, but it is just 1 times x minus y in a first expression and 1 times x minus y in a second expression. So the answer is x minus y. But what about the LCM? LCM will be like before. First, the common in both the expression, that is x minus y, and the remaining which are not common in both the expressions, that is x plus y, x, and one more times x minus y, and hence the LCM is concluded. So this was for question number 2. Now next is question number 3. In question number 3, you can see the first expression is x cube 2x square plus x. Second expression is x square y plus 2xy plus y. Let us take first expression. In short, I have written exp here. X cube plus 2x square plus x. And the first rule, first concept of factorization is to take common x cube, x square and x. So there is at least one x in all the 3 terms. So you can take common x. We'll get here x square plus 2x plus. Now if one x is out, then there will be nothing left. That is, there will be 1 in a product form, because there is x times 1 is x. So we don't write 1 here in the expression, but we can write here 1 while taking x out of the expression. Now you can see this goes in a formula of a square plus 2ab plus b square. So we can return back this term here. So for that, let us check. X square plus 2x, we just have 2 times x is 2x. We can put 1 from our side, the meaning will be equal to 2x, and we can put 1 as 1 square, because the square of 1 is also the 1. But what can we compare is the formula, that is x will be taken as a, 1 will be taken as b. So if they match with the formula a square plus 2ab plus b square, then we can write them in a form of a plus b whole square, that is x plus 1 whole square. So the answer will be x plus 1 times x plus 1. Now the second expression is equals to x square y plus 2xy plus y. And here we see y, and y is common in both. We'll be taking y common. Then we'll have x square plus 2x plus 1. Luckily, just now we have solved this in the previous expression. So you can directly write the outcome of x square plus 2x plus 1 is x plus 1 whole square, because we have understood it. Or you can do this process once again for the second expression also. Y x plus 1 more times x plus 1. Now the HCF of these two expressions is the common in both the expression. X plus 1 is common. Very good. X plus 1 is common. One more times. Good. So we'll write here x plus 1 and x plus 1. But about LCM, the concept of LCM is that first we have to take which is common in both. So common in both is the HCF, that is x plus 1 and x plus 1. Now the rest which are left, that is x is left from here and y is left from here. So x and y. So you can conclude writing xy in front and x plus 1 multiplied x plus 1. I hope there is no any confusion related this example also. Now let us go for the fourth example. In fourth example, the expressions are 5x square plus 10x plus 5, and the second expression is 7x cube 14x square plus 7x. So first expression we'll be writing as 5x square plus 10x plus 5, and if you carefully understand the question, then 5, 10 and 5 are the multiple of 5. So we can take 5 as a common number taken out, then x square, 5 times 2 is 10, 2x, and 5 times 1 is 1. One more time we got the same expression as that of question number 3. So we can directly write, if we have keep in mind that this is the square of x plus 1 whole square. So x plus 1 plus x plus 1. And if you are not sure, then you can go the long process which I have done in question number 3. Now second expression, that is 7x cube plus 14x square plus 7x, and you can see 7, 14 and 7 are the multiple of 7. So we can take 7 out from the expression. X and x contains at least one x in the expression, so we can take x also out from the expression. We will get x square, 7 times 2 is 14, 1x is out and 1x is left, and 7x, all of the terms are out, so nothing is left, it means there is 1. So the same expression like before, x square plus 2x plus 1, which is equals to x plus 1 whole square, so we can break as x 7x, x plus 1, x plus 1. Therefore, the HCF is the common in both x plus 1 and x plus 1. And about the LCM, we'll have to take common in both, that is x plus 1 and x plus 1, and the rest will also be followed back. So 5 is left, which is not common. 7x is left, which is not common here. So finally we can conclude 7 times 5 is 35x, x plus 1 and x plus 1. So it is almost similar to that of question number 3. Now let's go in question number 5. In question number 5, the first expression is x power 4 plus 4, and the second expression is 2x cubed 4x square plus 4x. Then we will write here first expression, that is equals to x power 4 plus 4. Now here we are going to understand something different in factorization. X power 4 can be changed to x square times whole square, and 4 can be changed to 2 times whole square. Here we are making the formula like a square plus b square, and in the previous video I have explained you, while factorization we must always take the above first formula from a square plus b square. So x square will be like a square, 2 will be like b here in the formula, then we'll get a plus b whole square minus 2 is in the formula, a is x square and b is 2. After that we will be writing x square plus 2 whole square minus 2 multiplied by 2 will get 4x square. X square plus 2 whole square. Now 4x square can be changed to 2x whole square. It means 4 is the square of 2, x square will be taken as x inside and square outside. Now x square plus 2 will be taken as a and 2x will be taken as b. Then you can match with the formula a square minus b square. And mostly these two formulas are very important while finding the HCF and LCM in algebraic equations. Most of the cases these two formulas are highly used. Now first we have used a square plus b square here. Now we are going to use a square minus b square here, because they look like a whole square minus b whole square. Then you will be writing a plus b. Again you will be writing a and minus b. You can arrange them x square plus 2x plus 2 in a decreasing order of power of x, and you can write here x square minus 2x plus 2. This was of the for the first expression. Now we will be writing for the second expression. We will not drop the answer here for the first expression. In a second expression, our question is 2x cube minus 4x square plus 4x, and you can see 2, 4 and 4 are the multiple of 2. So we will take 2 common, x cube, x square and x. Actually there is one x common in all of them. So the remaining number will be x square minus 2 times 2 is 4, x square and x, and plus 2 times 2 is 4. After that, let us find the HCF. So how we concluded this? Because we have understood, we have checked that it will never go to the square form. So, and neither it can be broken down in a midterm form. So we have to conclude this as an answer. Now the common in both is x square minus 2x plus 2. So we will be writing the x square minus 2x plus 2 as HCF. And one more hint that we have to stop up to here, because we are matching with the solution of the first expression here. So by that also you can conclude we cannot break any more for this expression. And after that HCF, we have to find the LCM. So in LCM, first we have to copy the HCF and the remaining terms will be followed as it is. This is not common, so x square plus 2x plus 2, and 2x is not common, we can write 2x in the front, and hence the answer of 5 is here. Now let us go for answer of question number 6. For question number 6, the first expression is x cube plus 8 and the second expression is x cube minus 2x square plus 4x. It means let us understand about the first expression, that is x cube plus 8. Here we are going to use another formula of a cube plus b cube. After these two formulas, the mostly used formulas are a cube plus b cube also. Now you can see here x can be taken as whole cube, it's okay. 8 is the cube of 2. It means 2 whole cube. Now they look like a cube plus b cube. We have to put them in the formula like a plus b and a square minus a b plus b square. Then here we will find that square of x is x square minus 2x is 2x plus square of 2 is 4, and this much for this expression, because this expression will not be divided by the midterm formula or neither be used in any type of a plus b or a minus b formula. Now next is second expression, and you may keep in your, you can ask again how it is possible not to break this, because you can check if you can arrange or you can compare with the given these two formulas. Minus is here, try to break in this form, you will never find the square of it. You can check, let us see, x square minus 2ab, the b is 1, but here b looks like 2 whole square, and hence because here is 2, here must be 2, but we don't have 2, we just have 2 here, we don't have 2 times 2 is 4. To be really put into a formula there must be 4x, but we just have 2x, so we don't break that expression anymore. Now let us go for the second expression and we can conclude why it is not breakable then, because we will get one expression similar to this, x is cube minus 2x square plus 4x. Neither of the digits are common here, but the variables are common, that is x, and we will get x square minus 2x plus 4, which is almost common to the previous expression, so we are not going to break anymore for this expression. Therefore HCF is x square minus 2x plus 4. But when we talk about the LCM, then the LCM is x square minus 2x plus 4, as it is HCF because it is common in both the expressions, but x plus 2 is not common, so simply we will copy, and x is not common, so we will also copy that. So in HCF we will just copy everything. First we will try our best if they are common. If they are not common, will also be copied down. After that 6 number, the last question is 7 number, that is needed to understand for grade 10 students, because that is an important question for students in grade 8, 9 and 10. Let us solve that. First expression, x square y square whole square plus 1 plus y square x square whole square. So I am directly solving about first expression first. So what we can understand here, here it is in a square form, here it is in a square form. We got 1 in the middle. So let us keep that in a corner. X square y square whole square plus y square x square whole square plus 1 in a corner. 1 has nothing to do here. Now main thing we are going to do with these two terms, and let us consider this as a whole as a, this all whole as a and this all whole as a b, then it looks like a square plus b square. So we will change in a plus b whole square minus 2, a is x square y square into b is y square x square, and plus 1 is here being followed. Now what can we see? Y square and y square, x square and x square are cancelled. 2 is left alone, x square y square plus y square x square whole square minus 2 plus 1. So here what can you see? Minus 2 plus 1 will give you a value of minus 1, and 1 can be kept in a square form, the answer comes 1. So you can see this all condition will look like a square minus b square. Now again, after using the formula of a square plus b square, we have gone back to a square minus b square also. So now we are going to put this formula in the form of a square minus b square. This all term will be taken as a and this one will be taken as b. So we will be writing like x a, all the terms as a plus b means 1, a plus b. Now one more time, x square y square x square minus 1, like a minus b. This all term will be taken as a and this one will be taken as b. Now let us go for the second expression. But while solving the second expression, I am not going to draw the solution of the first expression. We have to compare for the HCF. Second expression. In the second expression looks like a cube formula, y by x whole cube. Equals to, this formula looks like a cube plus b cube, a plus b, and a square minus a b plus b square. Then you will find here x by y plus y by x, and here opening the brackets you get x square y square. This x and y are cancelled. You can write minus 1 plus you will get y square x square. You can see it looks similar with this term. Minus is in the corner. If you rearrange, then you will find same. It means the LCM or the HCF is x square by y square plus y square by x square minus 1. This term and this term is common in both the expressions. And if we talk about the LCM, you have to take this term as it is. You can write the LCM after finding the HCF. Now for LCM, the HCF will be copied as it is, and the remaining parts which are not common will also be copied. X square y square x square plus 1, and this term x upon y plus y upon x, and hence the solution of HCF LCM is found for all the given 7 questions. So this much for this video. If you have some other questions related to HCF and LCM, then don't forget to put your questions in the comments of this video down. And if you really like this video, then don't forget to share this video among your friends, of your classmates, so that they can also get benefited from this video. So till then, don't forget to share this video and subscribe to the channel, and keep practicing, keep learning. Bye.